Hello, I'm Carl Rowland with Sherline Products. In this video, we're going to go over G96, which is constant surface speed. Okay, this is very effective when you're doing lathe work, and especially if you're doing facing cuts or cuts where you're starting at a larger diameter and turning down to a smaller diameter. Okay, so some explanations first. Every material has an SFM value, which stands for surface feet per minute, okay? And the harder the material, the lower the SFM value is, okay? So if you use the SFM value in a formula, you can figure out what your maximum spindle RPM should be, either for a given diameter that you're turning or for the diameter of a tool, say if you're drilling a hole, okay? So the formula to figure out your max spindle speed is 3.82 times the SFM for that material. Okay, then you take that value and you divide it by either the diameter of the drill you're using or the actual diameter that you're cutting when you're turning on the lathe. Okay, using that formula, as your diameters get smaller, your RPMs increase. Okay, and as the diameter gets larger, your RPMs slow down. So where this comes in handy on facing is and we'll show a program. I'm gonna just cut air, but it's gonna start at 3 inches, okay? It's going to face down to 0, and it's gonna face back out to 3 inches, and you'll get to see the RPMs increase and decrease as the diameter changes, okay? Then it's gonna go to 1 inch and feed out. And at 1 inch, whatever maximum spindle speed you calculated with that formula, that value divided by 1 is going to be that value. So the RPMs that show on the screen should be exactly what you calculated using the SFM in that formula. Okay? So right now, we're going to open up the program. Okay, and this one is just called G96 Test. And I'm going to load it. And I'm going to go to Edit, okay? There's a sequence that you have to put in to make the G96 code work, okay? In your program, the line before the G96 line has to be a spindle speed, just S2800. I put in 2800 because that's the max spindle speed for our headstock spindle, okay? If you can go faster than that, fine, as long as you don't exceed the speed for the material that you're cutting, okay? So we're going to be cutting 12L14 steel, which has an SFM of 180, and this is when you're calculating for high-speed steel. On the next line, so it's going to go S2800, the next line is going to be G96, D, and the D is going to be the max RPM that you want it to go to. So I put 2800 in there. And then the S value is the surface feet per minute for that material. So I've got G96, D2800, S180. So that sets all that information into the computer. The next line of code, you're just going to put an MO3 in there, okay? And that's just to turn the spindle on. Your feed rate and I take it back, your spindle speed, once you put the G96 in there, will be dictated by the calculations of the controller, okay? One note on this, in the calculations, they're using feed per minute in sync with the RPM, okay? You cannot use G95, which is feed per rev, if you're using a G96. And the feed rate that you will use is going to be inches per minute, which is G94. So further down in my program, I make a couple rapid moves, and then on my first cutting move, I'm going to X 0.0, and I have a feed of 5.0. That feed is 5 inches per minute. The actual feed that it goes at is going to be in relationship to the RPM, okay? So right now I'm going to exit out of this, and I'm going to load it. And what you'll see, if you look up here, you'll see the RPMs that's actually turning along with the diameter that the cutter's at. And you'll see it's going to start at 3 inches a minute. And as it cuts towards the middle of the part to 0, the RPMs are going to pick up to 2800. As it feeds back out, the RPMs are going to drop down to much lower than that, in a 200 range. Then it's going to feed back into 1 inch and feed out. At 1 inch, whatever you calculated for your maximum spindle speed using that formula, that's what it should be at 1 inch, because that value divided by 1 is that value. So I loaded the program, and now we're going to run it. And like I said, it's just going to cut errors just to show you the different diameters and the RPM change. So I'm going to hit rewind and start. And right now it's up at 2700. It's going to 3 inches. At 3 inches, and it's moving in. And our RPMs are at 270, 350, and it's climbing as it goes to X0. And you can see on the screen the RPMs that it's running, and also your diameter. At 0, we were close to 2800. Okay, now it's moving back out to 3 inches, and you can see the RPMs drop. Now it's going to feed back into 1 inch, and at a SFM of 180, the RPM should be right around 687. So it's feeding out, and it's reading about 672 right there. Okay, so wait for it to end here. Okay, so the other place that this comes in handy is if you're doing a facing cut, and if you're not using G96 and you just have an RPM in there, say 2000 or whatever, as it's getting to the smaller diameters, the RPM should actually be much higher. And you'll notice that if your RPMs don't change, then you're going to have a really nice finish where on the diameters where the RPM is the correct range. And when you get closer to the middle, the finish is going to get worse, and that's because you're not spinning it fast enough for that diameter when it's facing it off. Okay, the other one is if you don't use it and you're doing turning operations. Let's say I put in, for a 2-inch diameter stock, let's say I put in an RPM of 1000, and I have a feed per revolution. 1000 at a feed of 3 thousandths per revolution might be fine for my diameter of 2 inch, but as I go into smaller diameters, the feed is still going the same, the RPMs are the same, and the load on the motor is much higher because the RPMs aren't picking up, okay? The converse of that is if I have an RPM that's too fast, my feed and speeds at the outside are most likely going to be way too fast, which means I'm going to start burning the tip of my cutting tool off. I'm going to get blue chips. And then as I move into smaller diameters, then that RPM range is correct. So the G96 comes in very handy. To cancel the G96 at the end of the program, you just put on G97. So if I was doing a turning operation, facing operation, and I want to use G96, I would use it. If I go to drilling operation, center drill, I can just put a G97 in there, and then I can either put G94 or G95 for either feed per minute or feed per revolution for the remaining tools in the program.